Hello everyone, my name is Samuel Osong and welcome back to my YouTube channel. In the previous video, we looked at load balancing where we used HA proxy both as a load balancer and as a reverse proxy. For today's video, we are going to focus on SSL certificates and how to properly secure traffic within the same infrastructure. So today's video is a direct continuation of the last one. So the load balancing setup we built earlier is a major prerequisite for today's lesson because we'll be extending and securing the existing environment rather than building everything from scratch. Before we continue, please take a moment to subscribe to my channel, like this video, and also share it with your friends and anyone who might find this lesson helpful. So as always, your support really helps the channel grow. Thank you, and let us get started. So the importance of traffic encryption cannot be overemphasized. But one very common mistake I see is that people think SSL is something you just turn on once on your website or on your server, and then you are done. But then in real infrastructure, SSL is a part of your architecture design. So in today's lesson, I am going to walk you through how certificates are actually issued, how to deploy SSL on HA proxy. Then we will also secure only the front end, this part, all right? Then clearly we'll see what parts of our traffic is not encrypted before we will move to self-signed certificates and internal encryption. So for our lab today, just like I said, today's video is an extension of our HA proxy video. So if you are yet to see the HA proxy video, I recommend that you watch the HA proxy and the load balancing video so that you get a deeper understanding of what we are doing here in this video. So for our lab, I have created 3 servers on AWS. So one server is hosting the HA proxy and 2 servers are hosting our web application. All right. So HA proxy is in charge of balancing this traffic. All right. So if we view the HA proxy public IP on the browser, we should see that it is balancing between these 2 loads. So our very first part is to see how certificates are really issued. So before we get to the practical aspects, we must understand the whole process involved in getting SSL certificate. So first, the very first terminologies you will always come across is CA. So CA stands for Certificate Authority. So the job of a CA is to sign certificates and vouch for identities. So now CA is divided into 2. So we have the public CA and we also have the private CAs. So public CAs include authorities like Let's Encrypt, authorities like DigiSet, authorities like Sectigo, GlobalSign, and Entrust. We have etc. etc. So now for our public CA, your browser, your operating system already trusts these CAs. All right. So inside your own infrastructure, we also run our own private CAs. Okay. So now let us look at what is inside a certificate. A typical certificate contains a public key. It also contains identity. So you can look at identity as your DNS or your IP. All right. Then it also contains a validity period. And last but not the least, it also contains the certificate authority signature. So a private key is never inside the certificate. So another common term you will always see is CSR. So CSR stands for certificate signing request. So what a CSR contains is the public key, the identity information, and also it contains a proof that the requester owns the private key. So now let us look at the real life cycle of how these two guys come together. So what happens is that a server generates a private key. Now, a CSR, which is a certificate signing request, is created from that key. Then this CSR is now sent to a certificate authority. All right. So now the authority validates the requester and the certificate authority signs the CSR. Then the certificate is returned and you can now install it in your server. So this is how it all works. To repeat, a server generates a private key. Now a CSR is created from this key. Now the CSR is sent to a CA, which is the certificate authority. All right. Then the CA validates the requester. Then the CA signs the CSR. Then your certificate is returned. So finally, you install the certificate on your server for use. All right. So when people say self-signed certificate, all right, self-signed certificate simply means that the same machine acts as both the server and the CA. So for this lab, or for this video rather, we are going to use Let's Encrypt for our public traffic. All right, we are going to use Let's Encrypt. Let's Encrypt is a certificate authority. So we are going to use Let's Encrypt, all right, for our public traffic. Now, in the later end of this video, we are also going to look at self-signed certificates, all right? So now that we have seen how certificate is being issued, so we should go to the practical aspect. So I have created 3 servers, all right? So for the very first demonstration, we are only going to secure just the front end. All right. Now, the front end forwards traffic from the user to the back end. All right. So we are going to secure just the front end. Then we are going to also look at what is exactly wrong with this configuration. Then we are going to modify this architecture a little and move forward. So with that, I am going to log in into my HA proxy server so that we can start the configuration. So now, before certifications are actually issued by a certificate authority, your server must be mapped to a DNS. Yes, your server must be mapped to a domain name service. So in here, I have a domain on Namecheap. All right. So I am going to map my HA proxy server to my Namecheap. So I'll add an A record here. Then this is my HA proxy public IP. So I will also add an alias record to point to our root domain. All right, guys, so we have our two records set up, and sometimes it takes up to 48 hours for domain name propagation. So to confirm, we can use the DNS propagation checker, all right, to check if our domain name has been propagated. All right, guys, so in here, I'm going to type in my domain name and search. All right, so right now, our domain has been propagated except in Mexico. So I can go ahead and type in sam1.store, and this should be mapped correctly to my HA proxy server. Let me open this in, and all right. So my domain name has been mapped to sam1.store. So we can now go ahead to request a certificate from Let's Encrypt. So let me log into the HA proxy server. All right. SSH-I, then my key, my username, and my password. All right, guys. The first thing we are going to do is to update our server. Sudo apt update. So we give it a second, and our packages will be updated. So we are going to install setbot. You are going to install setbot. All right. So setbot is a free automated tool that helps you get and manage SSL certificates from Let's Encrypt. So to interact with Let's Encrypt, we use setbot. So to install setbot, we do sudo apt install setbot. So I'll use the -y flag. All right. So we'll give it some time, and our setbot will be installed. So for a second, we are going to stop HA proxy because HA proxy is currently listening on port 80, all right? And setbot needs that port to complete an ACME challenge, all right? So that Let's Encrypt verifies that we control the domain. So sudo system ctl stop HA proxy. All right. So the next thing is for us to request for the certificate. So we use sudo setbot set only because we don't want setbot to install the certificate for us. Then we use --- standalone, then -d for domain, and so we are getting to a certificate for our two domains, sam1.store and the subdomain, which is www.sam1.store. So we do sam1.store -d www.sam1.store. All right, so we hit enter. So we are asked to enter an email address. All right, so this will be used for renewal and also for security notice. So I'll add my email address. All right. Now you will be asked if you have read the terms of service in order to register with the ACME server. All right. So I'll say yes. Then I'll also say yes because I'm also interested in their marketing materials. So our account is registered and we are currently requesting a certificate for sam1.store and www.sam1.store. So if you check we have successfully received our certificate and our certificate is saved at /etc/let's encrypt/live and this. So we have our certificate, which is the full chain, and we also have our key, which is also saved as private key.pem in this location. All right. So now, why do we have the full chain and private key? So private key is the private key of our HA proxy server, all right? And the set.pem, yes, and the set.pem is more like a leaf certificate. Then the full chain.pem is our certificate plus chain, all right? Then if you check, you also see a chain.pem, all right? And that is more like our intermediate CA. So the next thing will be for us to combine our certificate and also our key into one file. So for that, I will do sudo sh-c. Then I'm going to cut this. So I am using sudo-c, sudo sh-c, then because I'm going to add a redirection later. All right. So redirection is done by the by your shell. So without the sudo sh-c, the shell would not have permission to write. All right, because I want to write into the /etc/ha proxy folder. All right. So let us continue. So I'll cut these two guys together, which is /etc/let's encrypt. All right, /live/sam1.store /fullchain.pem. All right, then the next one /etc/what again? Let's encrypt. Let me just copy this. All right. So now we can now have our redirection here. Our redirection will happen at /etc. So I want to store this in the HA proxy file or directory rather. All right. So I'm going to call this sam1.pem. Please let me use just single quotes. So if I hit enter, then I have combined these two guys into one file. So if I go to cd/etc, all right, /ha proxy, then if I do ls, I should see sam1.pem. So this is what we are going to serve in our HA proxy configuration file. So, and the main reason we also concatenated these two guys is because HA proxy expects the certificate first and then the private key. All right. So now this is the path to my certificates. All right. So I'm going to make sure I have this /etc/let's HA proxy because we are going to make reference to this guy later. So let us go to our HA proxy configuration file, which is this guy here. All right. So I'll do sudo. I'll use nano for it. Nano HA proxy. All right. So now, since we are only securing our front end, all right. So what I will do is I'll come here. Initially we bound our HA proxy server to port 80. So we are going to change this since we are now serving on port 443. So I'll change this to 443 and include our certificate. So our certificate is in this directory. All right. And the name of our certificate is sam1.pem. So we'll save this. This is just what we need to do. So I'll save this. All right, then let us check if our HA proxy configuration is correct. So I'll use HA proxy -c -f for the file, then the HA proxy configuration. So our configuration file is valid and we can safely restart HA proxy. Remember that we stopped HA proxy to complete our ACME challenge. All right, so I'll do sudo systemctl reload HA proxy. So our service is not active. Instead, I should restart HA proxy. So our HA proxy service has been restarted and it is currently listening on 443. So let us go back to our HA proxy. Yes, what our DNS name that we map to our HA proxy server and reload. So we should see that we can now access we can now access this on port 443. Let me open this in a private window. All right. So if I open this, if I click on this lock button, I can see that our connection is secured. All right. Then our CA can be confirmed to be Let's Encrypt. So now, at this point, our HA proxy is secured, which is just our front end. So now, front end only SSL is not enough because your load balancer terminates TLS. So after that, the traffic inside your network can still be intercepted, can still be modified, and it can still be spoofed. So we must also encrypt backend traffic. All right. So now what we are going to do is that each of these backend will sign itself. There are obviously two ways to do this. Each of these backend can sign itself. All right. Or we can provision a central server as our CA. All right. That will help us to sign our backends. So let us go with the first option. Then we also look at why each of these servers signing itself is not the best option. Then we can look at how we provision a central server that will act as a CA, all right, that will help us sign our backend servers. So now, let us log into our server one. So this is, I will take the IP address of our server one and SSH into server one. Sudo. So I'm going to download because this is where my SSH key is. So SSH-I, my key, then my username, the IP address. All right, guys, we are in our server one um, server. All right. So now the very first thing we are going to do is to generate a private key. Remember the steps of our of getting our certificates. All right. The first thing we do is to generate a private key. Then with that private key, we generate a certificate signing request, which we give to the CA, and the CA verify our identity and return our certificates back to us. All right. So the first step is to get a private key. So since this is a self-signed certification, so we are going to use the open SSL tool to get our self-signed certificate. So the first thing is to get a private key. So we do open SSL Jane RSA -out. Then I'll name this key backend dot key. Then I will use 2048-bit for this key. So if I hit enter, all right, then let me do ls. So this is our key, backend.key. So the next thing we are going to do, since this server is the one signing itself, we don't need to create a CSR because this server is the one signing itself, all right? So we'll just go straight to getting the certificate. So we do open SSL request -x509. This is you telling open SSL to skip CSR and go straight to issuing your certificate. -new, all right, then -key. The name of our key is backend.key, all right. Then we are going to use the SHA-256 hashing algorithm, all right. Then our certificate should last for 1 year. You can make it longer. It is self-signed, so you have the privilege to make it longer. So -this, I'll keep it at 1 year, 365, all right. Then -out. Then I'll give it backend dot self dot crt. So if I hit enter, so I think we missed something. Okay, this is not -care. This should be -key. All right. So let us edit this to key. So we hit enter. So you are about to be asked to enter information that will be completed into the certificate request. All right. What you're about to enter is what is called a distinguished name or a DN. So this is where you enter your country name. So mine is Nigeria, so I'll do NG. All right. Then instead of province, I can say Rivers. So you can just type anything here. All right. Then so now the common name is, I think, one of the most important thing here. So for the common name, remember that for our public certificates, all right, we had to map the server to a DNS name. But here, you can use anything as your common name, all right. But what I will do is I will say backend dot internal. You can use anything at all right. So this is just to keep mine very straight. So if I hit enter, then I'll be asked for an email address. All right. So I think that succeeded. So let us do ls. So we now have backend.self.crt. Let me use iPhone here. So you can skip all these guys. All right. So let me do all right. Let me delete this other one out. So rm backend dot All right. So I have just one certificate now. Backend-self.crt. So our self-signed certificate is ready. All right. So now, since my backend servers are running Nginx, all right. So I'm going to install this guy on my Nginx web server. All right. So now, but first, let me make a directory on my Nginx directories. All right. So I'll do sudo mkdir. I'll use the -p flag. Then this is where I can get nginx /etc/nginx. All right. Then /ssl. All right. So let me copy. I'll do sudo copy backend dot. Okay. All right. So this so I will copy this guy to my to this nginx directory. So sudo copy backend-self.crt /etc/nginx. All right. I made a mistake, guys. This is not the spelling of nginx. So I will have to rerun that first command again. All right. So I'll have to rerun this command again. So that I'll create the SSL folder inside the nginx root directory. So I think yes. So I can now copy sudo copy backend, all right, /etc/nginx/ssl. All right. So if I hit enter, and that works. So the next thing is for me to change my permissions, all right, so that just the users can have access to the key. So chmod sudo chmod 600 /etc/nginx/ssl. Then we can have the backend. All right. So the next thing is for us to open our nginx configuration file. So we can see the nginx configuration file at /etc/nginx/site available. All right. Then we are going to work on the default configuration file there. So I will do sudo nano /etc/nginx. All right. /site available, because this is where you see the nginx configuration file. Then the file we are looking for is default. So if we open this up, so the first server block is 80, which is for HTTP. So we are going to create our own server block. So we are going to create our own server block for 443. So we'll start with server. All right. So listen 443. So almost the same thing here. All right. Listen 443, then SSL. All right. Then what is our server name? Our server name is backend.internal. The common name you gave to OpenSSL. So backend.internal. All right. Then from here, we can give our SSL certificate SSL certificate. All right. SSL-certificate /etc/nginx/ssl/what backend -self.crt. Then another thing is our key, SSL certificate key. All right. /etc. So I did not copy. I also need to copy, although it is not a must. All right, but I also need to copy the key. All right, to this folder. So I will save this first, then I'll come back to this guy. All right. So this is our key, backend.key. So I'll do sudo copy backend.key. All right. So I'm copying it to /etc/nginx/ssl. All right. So I'm going to provide this path. So I can open this guy again, then edit our server. So here will be /nginx, the same path, /ssl, all right, /backend.key. So now the location of our web routes, this should be the final thing. Location, then our route is /var/www/html. All right. Then the same thing, index, then index.html. So we can close this guy and also close the first one. All right. So if everything looks good, I think they should work. So I will save this guy and exit. So I'll do sudo nginx-t. So our nginx configuration file failed. So all right. So let us go back to our configuration file. All right. So this is supposed to be closed and not open. So let us save this and retry again. Control O. All right, then X. So all right, so our configuration file is very okay. So we can now reload nginx. So I'll do sudo systemctl reload nginx. So all right, so for benefit of doubt, we should copy the IP address of server 1 and serve it, all right, so that we can see that this is a self-signed certificate, or even if we are going to see HTTPS, all right, but it is not trusted. All right, guys. So this is where we are. All right. So one thing you ought to know is that even if your certificate is self-signed, it does not automatically make your browser show HTTPS by default. All right. So, but to just clear a doubt, let me add S here. All right. So if I hit enter, we can see that there's a potential bricks. All right, because my CA, which is self-signed, and also my certificate, all right, which is a self-signed certificate, is not known by this browser. So if I come to advanced, you will see that this certificate, the certificate on my server is not trusted because it is self-signed. All right. So you can accept the risks and continue. Accept the risks and continue. All right. So this is basically a weak model. I think I am having issues with my routing on Nginx. But then this type of configuration, all right, because the same server is the one signing your request. This is basically a very weak model, all right, because when that server is compromised, and okay, this is basically not all. Before we go to the next stage, we'll need to tell HA proxy to we will need to tell HA proxy to also see that our backend server is working on HTTPS. So let me open up the HA proxy configuration file, which is sudo nano /etc/ HA proxy HA proxy config. So we'll come here and we ask HA proxy to verify none. So I'll change this 80 because our backend servers is now listing on 443. All right. So 443. I think this is the first one. This is for server 1. So 443, then SSL verify none. So I'll save this config, Control O, then Control X, then restart HA proxy. Sudo system ctl reload HA proxy. The unit file configuration file change on disk. Okay. Let me run sudo system ctl daemon reload. All right. So I hope we can now restart HA proxy now. All right. So this is our server 1. I misconfigured my route. All right. So this is my server 1, and if I should reload again, I hope the next request goes to server 2. All right. So you can repeat the same process for server 2. All right. Because I don't want this video to be too long. Then, like I said, this is a very weak model because our server, our backend servers is individually signing a request. But then for when you're looking at the aspect of security, we are going to use one central server. Then this central server is going to act as our certificate authority, and this central server will be in charge of signing this certificate. All right, so that HA proxy on the other hand will know who to trust, because there's no security without knowing who to trust. Because the whole essence of security, especially now, is zero trust. All right. So let us move to the next model, which I will consider a very strong model. So I am going to use HA proxy as our central certificate authority. So what happens is that why I'm using HA proxy, not really because HA proxy is special. You can create another dedicated server for this purpose. But while I am using HA proxy is because HA proxy in this configuration is a central machine. All right. So it connects to all backend. And so you can also assume with me that HA proxy is now or can act as a natural trust anchor. All right. So now we are going to create a private key on HA proxy. All right. So after creating the private key, then we are going to, from the private key, HA proxy is going to get a a certificate authority, I think key, yeah, something like that. So from there, we'll create a CSR, we'll generate a CSR from each of our servers, and then send the CSR to HA proxy to verify. All right. So this is my HA proxy server. So the first thing I'll do, I'll still use OpenSSL. I'll generate a private key. So I can call this key internal certificate authority dot key. Then I'll use a stronger bit here because this is like the trust anchor. All right, 96 4096. So this key is very powerful because it is going to sign other certificates. So if we do ls, we should see my key here, internal ca.key. So the next thing I'll do is to generate a certificate authority, a certificate authority certificate, yes, a CAC. So I'm going to generate a certificate authority certificate. So to do that, I'll still use OpenSSL, then this guy, iPhone X509, because I am skipping the CSR. All right, iPhone new, iPhone key. Our key is internal certificate authority key. All right, then iPhone this. So this guy is going to act as a certificate authority for 10 years. I'm just assuming, all right? So you can use 5 years, you can use 20, you can use 100 years. This is the beauty of self-signed certification. So iPhone days 3650. All right. Then I'll still use the SHA-256 hashing algorithm. SHA-256. All right. Then iPhone out. I'll call this certificate internal certificate.crt. Internal certificate.crt. I think this is all right. Okay. Again, I'm going to skip this. Then for my common name, I can use internal CA. All right. Or I can say ca.internal. ca.internal. All right. So I'll hit enter. So, and that is that. So if I do ls, I should see my certificate. So we are going to use this certificate to sign the other guys. All right. So this is still my server 1. All right. So I'll come to server 1 and create a CSR. That is a certificate signing request. Then we'll take that CSR to the HA proxy server. Then HA proxy server is going to sign the CSR, give us a certificate, and we take it back to server 1. So I think in 3 steps we should be done. So first, let us create a CSR in server 1. So let me clear this out. Then open SSL. All right. iPhone new. So if you check, the first step is always to create a private key, right? But I already have a key, so I wouldn't want to generate another key again. But when you're practicing, you use another key for this. So open SSR, required, iPhone new, iPhone key, backend.key. All right. Then iPhone out. So I can say backend. Then so let me use certificate authority of HA proxy, backend iPhone ca.csr. All right. So if I hit enter, and should ask me some few questions, then for my common name, I will just say backend ca dot, or backend csr rather dot. This does not really matter, but internal. All right. Please enter the following extra attribute to be sent with your certificate request. So a challenge password. So I can just, okay, 4 bytes. So maybe I can just type Sammy, SAMMY. Optional company name, I'll skip this. All right. So if I do ls, this is my CSR. All right. So I'm going to copy this CSR to my server one. Sorry, my HA proxy server. All right. So this is the IP address of my HA proxy server should be this guy. Second, guys. Let me copy this so that I can, my AWS has just locked me out. So I want to use a simple copy command. So dig this guy. All right. So server. Oh. I hope I get. All right. So this is all right. Let me confirm. All right. So this should be my IP address for the HA proxy. All right. So I'll use a simple copy. Let me keep this side by side. So I'll do SCP-I, then my key. All right. Then Ubuntu, then the IP address of this guy. Sorry. All right. Where do I want to copy it to? /home/Ubuntu. So I missed a step here. So after the private key should be what I want to copy. So it should be backend ca.csr. All right. So if I hit enter and come to my HA proxy server, I should have backend ca.csr. All right, guys. So the next thing I'll do is to sign this guy and return it back to our server one. All right. So to sign on HA proxy, I'll need the CA certificate. All right. And also, this is what I'll use. I'll use the key, the certificate, then sign this guy to return a server one certificate for me. All right. So what I'll do is open SSL X 509. All right. iPhone REQ -in. So this is our backend ca.csr. All right. -ca. And our ca is what? Internal ca.crt. That's the certificate we are using to sign. All right. Then the certificate key, iPhone CA key. All right. Internal certificate dot key. All right. Then we are going to create a serial database. All right. So we use iPhone CA. then create serial, then -out, backend. So I'll call this backend ca.crt. All right. Then how many days should this guy last? So I can say 365. Then use SHA-256 hashing algorithm. So I hope this works. So if I certificate request self signature, all right, okay. All right. So if I do ls, I should see backend ca.crt here. So I'll copy this guy back to my server 1. All right. So I'll do scp again, -i. So this is my, I have to copy my key to each of these servers so that it will be very easy for me. But this is not wise, but for demo purpose. Or if you do, you can safely delete your key afterwards. All right. So what am I copying? I'm copying backend -ca.crt. All right. Then Ubuntu. This should be my, okay. All right. So I think I really need to log into my AWS account. A second, guys. Let me log into my AWS account. All right. So I'm here. So let me copy my my public IP address for server 1. All right, because I'm copying the new certificate back to server 1. So I think, all right, this is where I am. So I'll paste this guy, and where do I want to put it? Into /home/Ubuntu. All right. So if I hit enter, and my certificate should be there. So if I come back to server 1, if I do ls, I should see this guy here. So now, guys, the next thing I'll do is to copy this back to our Nginx folder. All right. So sudo cp backend -ca.crt, all right, /etc/nginx/ssl. So if I hit enter, then we can now open our Nginx configuration file again, sudo nano /etc/nginx/ /site available. All right, then we are opening default. But before then, we will need to copy this guy. So I'll get the correct file name. So default. So if I hit enter, so what I'll do is to replace, because since we are using the same private key, all right, so nothing changes. So the only thing that will change is our certificate. So I'll replace this with this, or okay, yes, I'll replace this with this. All right, then that should work. So Control X or Control O for save, and Control X for exit. Then we will come back to HAProxy configuration file. All right, we'll come back to, okay, before we come back to HAProxy configuration file, then let us reload Nginx. So sudo systemctl reload Nginx. All right, so we'll come back to HAProxy and also edit our configuration file. Sudo nano /etc/HAProxy, then the HAProxy configuration file. So the final part is now the trust. All right, so we are going to enforce trust on HAProxy. This is what we are doing. All right. So, okay, before I do this, let me do ls again. So I'm going to copy the HA proxy, sorry, we are going to copy these two guys. All right, the CRT and the key, or maybe just the CRT, because the CRTs is what we use to sign certificates for other servers. So I'm going to copy just the CRT, the certificate, to so let me just make a directory /etc/HA proxy. All right, so I'll call this CA. All right, so let me move this guy, sudo cp internal ca.crt. All right, then I'll take it to the folder we just created /etc/HA proxy/ca. If I hit enter, all right, so this is I'll need to get the name of this guy. So this is the name of this guy, internal ca.set. So this is what we are going to use to enforce trust. So I'll go back to sorry about that, sudo nano /etc/HA proxy. All right, then I'll open up this file. So we are basically not doing anything apart from enforcing trust. So yeah, so we are working with server 1. So now we are going to verify. All right, so verify required, then CA file. So where is our CA file? /etc /etc/what, guys, /HA proxy, all right, /CA, and this is the name of the file. All right, so I am going to save this, exit, then let us check if our configuration file is correct. HA proxy -c -f, then /etc/HA proxy. All right, then this. All right, so our configuration file is valid. All right, so now HA proxy now serves as our trust anchor. Okay, so nobody can impersonate our backend servers now, unlike when our backend servers were the ones signing themselves. Okay, so we can now restart HA proxy, sudo systemctl reload HA proxy. So, but this does not still mean that our backend server by default is going to show up HTTPS. All right, no, it's still a self-signed. All right, it is only trusted in your internal organization. All right, so now if we go back to this architecture, so your HA proxy is listening on 443. Your backend servers is also listening on 443. So these guys are self-signed, while these guys is from Let's Encrypt. So this answers our earlier question. If we cannot just verify, all right, the weak model still works, but it is not really practical. So the second model, which we use HA proxy to sign, works so well. So right now, what we have is we have a real CA, which is our HA proxy server, and HA proxy server now sign our backend certificates, and HA proxy verifies them. So this is how to handle proper internal TLS. So again, each backend can be its own CA, but then HA proxy will have to verify or will have to trust many CAs. And the worst is that a compromised backend becomes a signing authority. So that means using a single CA simplifies trust. It can also simplify rotation in the long run, and it can easily revoke your certificate. All right, so it simplifies revocation and also limits blast radius. So even if it is a small infrastructure, you should also prefer a central CV. So guys, in this video, you saw how certificates are really issued, all right? And we took time to explain what a CA and a CSR really are. Then we also walked through front-end TLS with less encrypt. And then we also see self-signed certification with the weak model and the strong model. So this is what a real production grade traffic encryption looks like in a modern infrastructure. So if this video helped you, please do well to subscribe to this channel, like this video, give a comment, and share it with your friends. So I'll see you on the next one. Thank you guys.